So 3D triangles. So with this sketch, we are just going to showcase a few ways that you want to tackle 3D triangles questions. So if this is what you are looking for, you've definitely found it. Hi guys, Lever here from Bright Young Brains. With this 3D triangles question, they say that a plane cut is made through the block as shown in the diagram, revealing the triangular plane that has been formed. So we had like a cuboid, like a 3D rectangle, and then with that 3D rectangle, from the edge they cut it in that manner, which is forming like a triangle there. So if you do EGD, engineering, graphics, and design, then looking at this sketch should not be too bad. If you don't, then you just want to use your imagination a bit. And yeah, so with the shaded portion, we need to keep in mind that the line EF, that's like on top, the line FB, that's like on the side, and then the line EB, that's like in the front of your cuboid. Because to start off, this is what your shape looked like. You see there, we have the top portion, EHG. This here you could have even labeled it F. However, here at the bottom we have A, B, C, D. So we had a block, right? A cuboid. And then with this cuboid, where G is, B, E, they cut that tiny portion. And then with that portion cut off, we have that triangle there that is being formed. So with that triangle, they want us to answer these questions here. So with A, the first thing that they want us to do is to calculate the magnitude of angle EBG. So if we're going to get the magnitude of angle EBG, we want to keep in mind that EBG is this angle here. Let me might as well use that sketch. EBG is that angle there. Now, if you're going to get that angle there, trust me, the first thing you want to do is get as much information that you can in the sketch before you even worry about getting that angle. So with a sketch like this one, the other pieces of information that we are given is those dimensions there. The height of our cuboid is 8, the length is 6, and then the breadth is 15. So if you wanted to look at it like this is 15, this is 6, this is 15, this is 6, and then the height going up is 8. So answering A makes a bit more sense now. Calculate the magnitude of angle EBG. So if you're going to calculate EBG, trust me, the first thing you want to do is try and get all the dimensions of this triangle here. Get all the dimensions of EG, the dimensions of EB, and then the dimension of BG, as in the length of those lines. So luckily, we can start off with EB. Let's get the length of EB, and to get the length of EB, we can easily just use Pythagoras theorem, because you see, this is a block, or rather a rectangular prism, so we know that the edges are equal to 90 degrees. So getting EB, here we're seeing that EB is equal to 10. So let's just put here that there to help us in the future. So we have a length for EB. Now the next thing we can do for ourselves is to get a length for GB or BG, whichever way you want to call it. So getting BG, we want to think to ourselves, if we're looking at the triangle on the right portion, we know that BC is 15, and then the length of GC is technically going to be 8, because from the bottom going up, that's 8, because here you see from the bottom of your block going up, that is 8. So the distance of GC there is just 8, and then we can work out BG using Pythagoras as well. So using Pythagoras to get BG, here we're seeing that our value for BG is equal to 17. So let's throw that there. So what you want to take note of is, you see with a question like this one, whatever you work out, save it somewhere because you will need it. So here we have not even started in terms of getting the magnitude of EBG there, because we still need to do all this work. So the next portion obviously is we need to get the length of EG. Now the length of EG, you want to look at the triangle that is at the top there. Now the triangle at the top there, we know that if this is 15, that has to be 15 as well. And then if this is 6, this is going to be 6, and then up there it's also going to be 6. So hence why here HG, we know that's 6, EH, we know that's 15, and getting EG here we can use Pythagoras theorem as well. There we go. Our value for EG is 3 square root of 29. So at this point in time, we are somewhat ready to get the angle EBG, because if we think of where that triangle is, we know that this is its information now. We got EB, we got EG, and we got BG. You see, so whatever question you're given, don't think that you're just going to jump into it and get an answer. No, you need to like take a detour, get some answers, come back, and then use those answers. So here, getting now the angle EBG. Clearly, the one thing that should come to mind here, again, because we're working with 3D triangles, is you should be thinking of the cosine rule. Now, the idea with the cosine rule is, if you see that you have a bunch of information, like now, 3 sides given, and then you're looking for an angle, you're definitely going to need to use the cosine rule to help you answer this question. So in terms of us using the cosine rule now, we need to just write it out first. Now, writing out our cosine rule first. So this is what our cosine rule is going to look like. Now you may be asking yourself, how do we know that this is what our cosine rule should be mapped out as? So for you to be able to use your cosine rule, the one thing you want to look out for is, what angle are you dealing with? And then whatever angle you're dealing with, you want to identify what is its opposite side. So you see, the angle you're dealing with, whatever its opposite side is, it is always the length that goes there. Now the other two lines, in our case EB and BG, those will always be those two there, and then whatever these two are, it will be those two lengths there. So with your cosine rule, again, the more you use it, the easier it gets. So all we want to do now is to use our values to get the angle EBG. Now what I would recommend is, if you're going to work out an angle, try to algebraically make your angle the subject of the formula first, and then just throw in your values afterwards. However, not many people like that way of doing things, so it's best that we showcase it in this tutorial so that you see that it is actually not that difficult. So in terms of us isolating our angle there, the first thing we want to do is to take these two to the left. There we go. You've taken these two to the left. The next thing is, you want to divide both sides by the value in front of cos there. So dividing both sides by that value, this is what we're having. Cos EBG is equal to this entire expression. Now, obviously at this point here, you can throw in all your values and then eventually do your inverse of cos, as in shift cos your value to get the angle EBG there. But in our case, we are just going to do the full thing. Let's take cos over first before we throw in any values. So if you're going to take the cos over to the left, you need to use the inverse of cos. And then using the inverse of cos, all you want to do is, here we know that this whole thing goes inside your big bracket. So here we're going to have cos to the power of -1, and then our big bracket there, this should be equal to EBG. So obviously at this point in time, you're literally home free, because all you need to now do is these values for your letters here, You just want to get them from your triangle and then throw them in there, get your angle. So doing that, you're getting there, your angle for EBG is 67.88 degrees. So for a question like this one, it seems like it's way too long. However, there's no ways you are going to get this angle here without getting these dimensions here. And then those dimensions one by one. You see, we were actually using very simple methods. Pythagoras there, and there. And then all we did was we just needed to use our cosine rule here. And then we have there our angle for A. Now we are just going to work on B, calculating the area of triangle EBG. So for us to get the area of triangle EBG, all we want to remember is our area rule. Now our area rule looks something like that. Area is half AB multiplied by sine C. Now in our case, we need to map these variables with what our lengths in our sketch is. So what I mean is, whenever you use the area rule, you also want to think the same way that you do when you use the cosine rule, in the sense that your angle, you preferably want to make that an angle that you have, in the sense that in our case here, where C is, we want to position that here, because I mean we don't have any other angle in this sketch. Furthermore, these two lengths here will always be the ones that are next to your angle. So to rewrite this in order to accommodate our sketch, this is what we can write down there. Area is half EB times BG times sine B. You see this tiny angle here, it is just B. However, for a complex sketch like this, you may want to refer to it as EBG. However, if you had just put the B, that should be fine. So all we need to do now is throw in our values into our area formula and get the area. So throwing in those values, we are getting the 78.74. So for a question like this, I think this was a proper good question to showcase what you need to do when you work with 3D triangles. 3D triangle questions, remember, don't try and use your sketch all at once. You want to use portions of your sketch to help you work out whatever the main question is. And you see, it was literally just doing things step by step. So fun enough, if they had just from the get-go said get the area of this triangle, we would firstly need to do everything that we did, because we need to get that angle first, right? And then before getting that angle, we need to get all those dimensions. So none of the things that we did here is avoidable for you to answer any of these questions. So yeah, catch you in the next tutorial.